Hello students, welcome to the channel of Vedant classes. Okay, so in this lecture we start with the reflection through plane mirror. Okay, so let's make a figure for reflection through plane mirror. Let's consider this is a plane mirror. Okay, and let's consider a reference axis passing through the center of mirror. Okay, let's place the object somewhere over here. Now see, the distance of object from the mirror, it is denoted as u. So this distance is known as object distance. Okay, and here let's consider h, that is called height of object. So this is our object placed in front of plane mirror. Okay, now we need minimum of 2 rays to locate an image. Minimum 2 rays to get image. Okay, so as we require minimum of 2 rays, let's consider this point. Okay, now if you take it as incident ray, now you can see that incident ray is incident normally to the surface, and if incident ray is incident normally, then it will reflect back in the same path as theta and theta both will be equal to 0. So this is the first ray that we got, and the light ray is moving in this direction. Okay, you can see the light ray is moving in this direction after reflection through the plane mirror. Okay, now let's consider the second ray. Okay, so second ray will be incident at this point, so this will be our point of incidence. So this will be our incident ray. Okay, and it will reflect back in this way. So this will be our second reflected ray. Okay, now you can extend this both rays, then it will never meet at any point. Okay, they are going away from each other. So what we need to do, we just need to extend the light rays behind the mirror. Okay, so this will be like this, and this will be, okay, so this will be like this. Okay, so you get the image over here. Now see, we extended the light rays behind the mirror. Okay, so that is the reason we got the virtual image in this case. Okay, so we will get the virtual image because we extended the light rays. It is not intersecting directly, as these are the diverging rays. Okay, so the distance at which we get the image, that is called image distance. Okay, so this will be our image distance, and h dash will be our height of the image. So this is the image that we got. So this will be the ray diagram for the reflection through plane mirror. Okay, you can note these terminologies that we'll use in the entire chapter. H is the object height, then h dash will be the image height. Okay, u will be the object distance, and v will be the image distance. This terminology we'll use in the entire chapter. Okay, so now see, you can write it here as theta I and theta r. This both angle will be equal. Okay, here the light ray is incident normally. Okay, so now let's write the conclusion. Okay, the characteristic of the image that is obtained from the plane mirror. This is very important question. It is asked in the examination. It can be asked. Okay, so you can say characteristic, or you can say property, okay, of image obtained by plane mirror. Okay, so let's note down the characteristic of the image that is obtained by the plane mirror. Okay, so the first characteristic is, you can see that height of object, here it is h, the height of object, okay, here it is h, is equal to the height of image, that is h dash. So object height will always be equal to image height. Okay, when you look at the plane mirror, then it will show the same height as of yours. Okay, the height will never get changed in the case of plane mirror. Then secondly, object distance that is u will be equal to image distance, that will be equal to v. Okay, if you are standing 3 tiles behind the in front of the plane mirror, then your image will also be behind 3 tiles inside the plane mirror. Okay, so the object distance will also be equal to, will always be equal to the image distance. Then third point, this is very important point to note down. Okay, the image obtained is laterally inverted. Okay, what does it mean, laterally inverted? This is very important term. Okay, now see, in front of plane mirror, if you will pick your left hand, then the image will pick up its right hand. Okay, and if you will pick up your right hand, then image will pick up its left hand. Okay, so this type of terminology is called laterally inverted. The laterally inverted, where you can see the application of this one in practical life, you might have seen the application of this in ambulance. The word ambulance, that is written on the ambulance bus. Okay, now see, in plane mirror it forms the laterally inverted image. Okay, if in ambulance it is written like this. Okay, okay, so in ambulance it is written like this, so it's inverted image, you can see it in your glass. Okay, that you can see in your side glass of the mirror. So that is the reason, due to the lateral inversion, the ambulance word is written like this on the ambulance bus. Okay, now let's see its fourth property. The fourth property is virtual image and erect image is obtained. As we extended the light rays back behind the mirror, then it is virtual image. So that is the reason we are getting the virtual image in this case. And erect means upright, you can also call it as upright, means it is not inverted. Okay, this is straight, so this also will be a straight in a erect position. Okay, upright position you can say. Now one important note that I am going to mention here, that focal length, this is very important question, focal length of plane mirror is infinite. Okay, so focal length of plane mirror is infinite. So remember this one. See, as there is no curvature, so you never get any focal length of the plane mirror. So remember this important key point. Okay, take a screenshot of this, so we'll move ahead. Okay, now let's see the types of spherical mirror. So first type of spherical mirror is concave mirror. Okay, concave mirror. See, concave mirror is also called as convergent mirror. Okay, now see, convergent means you can say it, the light rays come closer and closer to each other. Okay, so convergent, you can simply remember rays comes closer. Okay, it is getting closer and closer to each other, that is called convergent. Okay, so how it forms, consider a spherical glass ball. Okay, this is spherical glass ball. Okay, and if you cut a part of glass from this, then it will be like this. Okay, it will be like this. Okay, now if you apply the silver, it is called silvering of mirror. Okay, if you apply the silver coating, okay, on the outer part, silver coating on the outer part, okay. Why silver coating? It is we deposit the silver coating because it reflect most of the light. So to get the reflection, we apply the silver coating on the outer part, and you can see the curvature reflecting surface in this part, okay. This will be your reflecting surface, okay. So this type of mirror is called concave mirror. So remember this thing. Secondly, convex mirror, okay. So second is convex mirror. So convex mirror is divergent mirror, okay. So what does the divergent? It is just an antonym of convergent, okay. Let's write its meaning. Divergent. Divergent means rays move away from each other, okay. So in this the rays will get closer and closer, so that is the reason it is called convergent, and here the rays will move away from each other, so that is the reason it's called divergent, okay. Now let's consider a spherical ball, okay. Spherical ball and glass ball, you can say, okay. This is spherical glass ball. Now if you cut the surface from it, then it will be like this, okay. So this time you just need to apply the silver coating in the inner part, okay. Apply the silver coating in the inner part, okay. So you will get the reflecting surface in the outer part. This will be your reflecting surface, and this type of mirror is called convex mirror, okay. So this is all about the types of spherical mirror, okay. Now let's solve the various questions that are based on laws of reflection and plane mirror, okay. It will help you to boost up your concept. So let's solve the first question. See, in the first question a figure is given like this, okay. This will be our incident ray, this will be our reflecting ray, and here the angle of incidence, you can see the angle is given 70. We need to find the theta I and theta r, okay. So in the previous lecture, if you have not seen, then just visit the previous lecture, okay. Like write that class 10 physics, okay, in the within classes, so you get the lecture number 1. So in that we have seen that theta and theta will always be equal, and angle must be always with the normal. So this is our surface of the mirror, and this will be our normal, okay. So if you want to find this angle, then it will be a 20 degree, just 90 minus theta, so it will be 20 degree. So here theta I will be 20 degree, and as according to the laws of reflection, theta and theta r both are same, so theta r will also be 20 degree, and here this angle, okay, this will be 20 degree, okay. Now let's solve the next question. See, in this next question they asked us to find the theta, okay. We need to calculate the theta. These two plane mirrors are given, and light is traveling like this. This is our incident ray, it incident on this plane mirror and then reflect again on the same path. This symbol shows that thing, okay. Now see, if it is retracing its path again, then it means that here it is incident normally, so it will be a 90 degree. Now if it is 90 degree, this is 50 degree, then according to the law of triangle, the sum of all three angles are 180, so this angle will be 40 degree, okay. Now as this angle is 40 degree and this is normal to the surface, this is our normal and n dash, and here if you apply 90 degree, then you will get this angle, okay, this outer angle, let's say alpha. So you will get the alpha is equal to 90 minus 40, so you will get that alpha angle equal to 50 degree, okay. And if this alpha is, here alpha is theta I, angle of incidence, so this theta will be equal to alpha according to the laws of reflection, so theta will always also be equal to 50 degree. So this is how you can, using the mathematics, simple maths, you can calculate the angle theta, okay. Now let's see the third question. In third question, the distance of object from mirror is 45 centimeter. Find the distance between object and its image, okay. Let's consider that this is a plane mirror. An object is placed somewhere over here. This is our object. Now this distance is given 45 centimeter. So at what distance its image will form? Its image I will form at the same distance. That's what we have learned. Object distance will always be equal to image distance. Now what you can say about the distance between object and its image? So it is clearly the distance d is equal to 45 plus 45. So your answer will be 90 centimeter. Okay. So you can see the distance between object and its image, that is 45 plus 45. So it will be 90 centimeter. Okay. So now let's solve the next question. Okay. So in the next question, they said that if a boy of height 165 centimeter standing in front of plane mirror at 1.5 meter. Okay. So let's just imagine the scenario. This is, let's say, a plane mirror that we are having. Okay. And here a boy is standing. Okay. So boy is standing in front of plane mirror at distance 1.5 meter. And a photo is there on a wall behind a boy. Let's say here we are having a wall and a photo is there on the wall. Okay, a photo is there on the wall, that is at 1 meter behind the boy. Okay, so first of all, the height of boy is 165 centimeter. So answer for the first one will be height of boy's image, so that will remain same. So answer for the first one will be 165 centimeter. Okay, now let's see the second one, the distance between boy and the image of photo. Okay, so you can see that image of boy will be here and image of photo will be somewhere over here. So this will be again 1.5 meter and this will be 1 meter. Okay, so now you can calculate the distance between this boy and the image. Okay, so that will be 1.5 plus 1.5 plus 1. Okay, so this distance will be 4 meter. This is how you can calculate the distance. Now let's solve the third question. Find the distance between photo and its image. Okay, so from here to here you need to find the distance. Let it be 1 plus 1.5 plus 1.5 plus 1. So the total net distance will be equal to 5 meter. Okay, 1 plus 1.5 plus 1.5 plus 1. Okay, so this is how you can solve the simple questions which are based on the plane mirror. Okay, take a screenshot of this one. Okay, so that's it from this lecture. Okay, keep learning, keep working hard. Please like, subscribe and share the channel if you are really finding it helpful. Okay, so thanks a lot.